Okay. All right. Well, I'm Beth Pratt Sitaula, one of the two Beths currently in the ECE portion of, who knew, right? I'm in the ECE portion of UNAVCO. I work part-time on things related to undergraduate education for UNAVCO. But what I'm going to present on here is was in the EarthScope innovation section in AGU on ways that different projects have leverage to more projects, larger projects with different audiences, much, I like to say, the same way that UNAVCO and EarthScope and Harrison has done with bringing together different arrays and things like that and going forward. So I want to make really clear that I am presenting on a lot of collaborative work. I'll be mentioning 5 projects, 4 of which I was personally involved in. So as Donna mentioned, we have a lot of really complex science going on, and so moving this from talking to ourselves in our science communities into letting people outside of our group know why it's important and what is relevant about it is quite a challenge. If you paraphrase the education and outreach goals of EarthScope, you can come to creating a high profile for EarthScope identity. You want to be working through informal education channels, so that's outside of the schools in parks and museums, community engagement, formal education, so through school channels, either K-12 or university. We want to see diverse use of data and discoveries, and to have a broad sense of community ownership. So these are the goals that have been framed to move forward on. And so what I will be talking about is sort of 2 tracks of many, that have been done to accomplish these goals. So the 2 tracks I'm going to mention today are working with educator professional development, a project related to teachers, a project related to interpreters, have moved into a current project called CTEP, which is bringing them together, and I'll talk about that more, in the Pacific Northwest for hazards, and a track of undergraduate geodesy teaching materials, which is what I'm working on more here for UNAVCO, talking about some seed efforts and then a new grant that we've had funded to do more coordinated curriculum development for undergraduates. So I'll start with a project called Teachers on the Leading Edge. This was active, well, there was actually a 2005 version, but the EarthScope funded was 2008 through 11. I was a co-PI on this, but I really want to point out that Bob Butler was by far the leader on that, and he's brought the rest of us in. And this was professional development workshops for K-12 teachers in Oregon and Washington to learn about the geohazards and the geology of that region. Why teach it generic when you have such great local examples, right? So what's really important, I think, in all of the education and outreach that goes on through EarthScope, UNAVCO, IRIS, is that you have to think of this continuum from the technical researcher and your end audience. And that is not like 2 points. Like, you have some other things you need to fill in order to make it translate effectively. So we have to get geology and earth science content from researchers who have good communication skills. So here's Bob, there's Shelley, this is Brian Atwater, the god of tsunami geology, Pacific Northwest. And we work with what we call master teachers, which are teachers that have much more higher content knowledge, and they practice it in their own classrooms, and they know how to tell this is how it works for 7th graders, this is how it works for 9th graders, and that sort of information. We also found that it was really crucial to get people into local teams. So we use community college instructors to give people these safe havens to ask questions that are, in a little regional group of people they might continue to work with. And finally, to make it easy to translate, you have to have kits and resources, digital, physical, just make it easy for them to take it into the classroom. So these are the sort of models that we set up that seem to be pretty effective. I'll tell you really quickly some of the data that let us feel like it was effective. This is content knowledge over these 3 years of workshops. Went on average from a D to a B in their understanding of Pacific Northwest geology and geohazards. teaching confidence. In some ways, we were even more excited about this. So they came in like on a 4-point scale of like how confident are you, very confident to a little bit or not confident. They moved from being a little bit confident, statistically significant pre-workshop, post-workshop, 1 year later, 3 years later, they continued to statistically improve, which is correlated with being willing to spend more time on this in the classroom, right? Classroom implementation, they took like 20 pieces of material that we gave them, and more than 3/4 of the teachers used more than 7 of the materials. So this is a high implementation rate for a 1-week workshop. So finally, to sort of sum it up in some numbers, the impact of total was spontaneously these teachers went out and hit over 1,500 other adults that they did professional development for, mostly co-teachers, also parents. And a conservative estimate by 2011, which was the last time we polled them, was more than 30,000 students had been reached by these 100 teachers. Concurrent to the Teachers Leading Edge project, total, what has been going on the EarthScope interpretive workshops, which were really led first by Bob Butler. I wasn't actually a participant or a runner of these, but it's a precursor to CTEP, which I am part of. So these are still ongoing. They're mentioned by Donna. And they hit many of the same topics as total, geohazards, local geology, whichever one it was. It wasn't just Cascadia in that case, it was the whole country as the array moved. But they were talking to park interpreters and museum interpreters, especially national parks. So some of the specialties about working in interpretation is you have people in these places that they often have strong emotional attachments to, these beautiful parks and things like that. And it's a great place to interest and inform them in geohazards learning and geoscience learning, right? Because it's much more visceral at that point. Another thing that they use a lot in interpretive workshops is telling the story. We heard that mentioned a couple of times. This is an example of how you can do an interpretive workshop with children, and they're each a tectonic plate. And that's a way to learn plate tectonics. This is an example. Interpreters are doing it here of what they plan to do. This is one of the during one of the workshops. So here's the plate basin and range. There's a GPS. There's a GPS. So they're acting out how the basin and range might form, right? Like, sorry, I'll just skip over. So numbers impact, if you just look at the number of visitors that have face-to-face with people that have been in an EarthScope workshop, like hundreds of thousands, and then overall visitors to these facilities are in the millions. So we took the knowledge, after the Japan earthquake in 2011, we said, maybe we can take these two knowledge bases of the formal and informal and translate that into a new project. So we're brought total together with the interpretive workshops and added emergency management educators, and we've made the Cascadia EarthScope Earthquake and Tsunami Education Program to particularly target all science and preparedness educators in these coastal communities. So over 3 years, we've done 2 workshops in Northern Oregon. This coming year, we're gearing up for Washington in the Olympic coast there. And then in 2015, we'll come down to Southern Oregon. So our overall aim is to improve disaster resilience by having these different educators learn geoscience, learn understanding the risks, taking action, and how to communicate all of these things to their people, their learners. And in the process, we're also researching what it's like, the challenges and benefits of bringing together diverse educators. They don't usually receive common professional development. But we justify it in particular in relation to geohazards because the social science research on behavioral change tells you that you need to hear, in order to make changes, the same message from trusted sources over and over and over again. So we can figure if we can get all the educators singing in harmony for a while, that we're hitting a lot of these points in social science. So we're moving up through the formal venue and the informal venue from the scientists up to what we hope through these educators to their students and public will be greater resilience overall. So far we've run 2 of these workshops with about 24 participants each. There's a share-a-thon that I'll be jumping on a plane and going to right after the science workshop. And we're using the same structure that we have developed in the previous ones. a lot of digital resources, physical resources, field trips, you know, put it into perspective of planning, telling stories. This is Juan de Fuca and Subduction Sally, and they came up with that themselves. And so far, the results that we've had on this are an increase in geoscience content knowledge, even better than we saw with total. Confidence that jumped so high on a 6-point scale, we're not sure if we could increase it statistically from there before and after the workshop. We've seen a change in optimism. I mean, we had a group of people that clearly were going to be pretty optimistic about the value of preparing yourself and your community and your family. But what we saw was that after our workshop, their emphasis and understanding of what you needed to do at the community level had definitely taken a jump. And they were in favor of this mixed pedagogy, you know, formal, informal educators coming together. So now moving on in my last few minutes to talking about the undergraduate, so we've sort of hit the educator professional development hard here. Now talking about the undergraduate geodesy teaching materials side of it. There had been a lot of requests for a long time from the UNAVCO community, like, look, we need to have ways to get this into the undergraduate classrooms more effectively. So we started about 2 years ago. I came on a very part-time basis to work towards the grant writing, but in that process, we inventoried sort of existing resources. We partnered with SERC, which is the Science Education Resource Center, the real go-to place for earth science, especially for university level. And they made a page called Teaching Geodesy, where we started to just pull in existing online resources, like, well, here's what's here at least, right? So this is a first place to go to sort of see what has been given by the community already. There was money left from the PBO ARA component to seed a module, which is about a week or so of time. You can go into a structural geology course called Infinitesimal Strain Analysis Using GPS Data. And so it was targeted, like I said, for a majors level geology, structural or geophysics course. And what it is, instead of studying smooshed fossils for finite strain, it got the students working with PBO data to look at ongoing strain. So and this was led by Vince Cronin. He'll be presenting on it more at the science workshop. But they take 3 stations and use a calculator to an Excel or MATLAB calculator to determine the overall strain field. And using the same sort of ideas, like you have this technology and science and you have this audience and you need to put some points in between. So we had the faculty developers on this, which is Vince and Phil, who will both be at the science workshop. Geodesy experts, they wanted to make sure that the calculator and the science was all correct. So we worked with Corné and Bill at Reno. And then from the ECE side, Shelley and Nancy and myself trying to make sure the pedagogy was good for this. So that served as sort of a seed idea for a project called Geodesy, which has been funded recently by the National Science Foundation, and I'm the logistical hub for that. And the idea is that we'll do geohazards, climate change, and water resources modules on a scale of 2 weeks of class time for introductory and majors level. This is a seed funding grant. Essentially, we can do 4 modules at this level. If we like how it goes, we hope for a second round of funding to do more if the community is using them. It's jointly with UNAVCO, Mount San Antonio in Indiana, and we're working with the Science Education Resource Center to evaluate and disseminate it. So we've chosen the initial topics of ice mass and sea level change for the intro level one. This is based on survey feedback and conversations with the community. Active tectonics with INSAR and LIDAR for the majors level. And this is from AGU, right? So we've had this webinar and it overfilled, and we've had another one as a way to get more community involvement on what's happening in geodesy and what they'd like to see.